We're going to continue graphing using roots and end behavior. First thing that we're going to do is find the roots for this polynomial. So I'm going to use synthetic division and take the coefficients. The number I'm going to guess is 1. So if I plug in, if I multiply it by 1, I get 1 and 0. 1 times 0 is 0, negative 7. Negative 7 is negative 6, and that gives me 1, 0. I'm going to try 2 next. So bring down the 1, 2, 2, that's 4, that's negative 3, that's negative 6, that does not work. So I'm going to try 3. 1, 3, 3, 9, 2, 6, that works. So what I have x minus 1, I have x minus 3, and I have x squared plus 3x plus 2, and that equals 0. So that means that I'm going to factor this, x minus 1, x minus 3, this is x plus 2, x plus 1. So that means my zeros would be 1, 3, negative 2, and negative 1. Now I'm going to find my end behavior. I'm going to take my leading degree, which is x to the 4th, and what I'm going to do is I'm going to replace it as x approaches negative infinity. I'm plugging in a negative 1. 4 negatives gives me a positive, so that means y approaches infinity. And then as x approaches infinity, so instead of a negative 1, I'm plugging in a 1. 4 positives is a positive, so y approaches infinity. I'm going to use my 6 as my y-intercept. So when I graph this, I have 1, 2, 3, and 1, 2, 3, and I go up to 6. What I have is, let's see, 1 and negative 1, 3 and negative 2. So far left, when it approaches negative infinity, it goes up. Far right, it goes up. I'm going to follow the points down, up, and down, and up again. Now, looking at letter E, with this one right here, synthetic division would take a little bit more time. I can clearly see that it's going to factor. So I'm going to set it equal to 0. I'm going to factor out a negative 2x, and that leaves me x squared minus 4. This right here, when I factor x squared minus 4, I get x minus 2 and x plus 2. So I have 3 zeros. I have 0 from the first one, 2, and negative 2. I'm going to look at my end behavior as x approaches negative infinity and as x approaches infinity. My leading term is negative 2x cubed, so I'm going to replace the x first with a negative 1 for the negative infinity. 3 negatives and then another negative is going to give me a positive. And then when I plug in a positive 1, 3 positives give me a positive, but then when I multiply it, I get a negative. Now I'm going to look for my y-intercept. My y-intercept, notice that there's no constant value, so it's going to be 0. When I graph this, what I have is negative 2 and 2 and 0. End behavior, as it goes to the left, it goes up. As it goes to the right, it goes down. So I follow the points, and that right there gives me my graph. Now, looking at letter F, I'm going to take my coefficients 2, 5, negative 5, negative 5, and 3, and I'm going to try 1. 2, 2, 7, 7, 2, 2, -3, and -3. I'm going to try, well, I know 2 is not going to work, so I'm going to try 3, 2, 6, 13. Ooh, this looks too large. I'm going to try -3. 2, -6, 1, -3, -1, and 3. So I have x minus 1, I have x plus 3, I have 2x squared plus x minus 1. That all equals 0. I'm going to factor this. -2 and 1, so that would be 2 and -1, but I have to divide it by 2. So I get x minus 1, x plus 3, x plus 1, and 2x minus 1. So my zeros are 1, -3, -1, and 1/2. Now what I'm going to do is I'm going to look at my end behavior. I have 2x to the 4th. So I have as x approaches -infinity, 4 negatives would be a positive times a positive would give me a positive. And then when I plug in a 1, as x approaches infinity, 4 positives and a positive gives me a positive. Now to graph it. I forgot my y-intercept, which is 3. So y equals 3. And when I'm looking at my intercepts, I have 1, I have -3, I have -1, and I have a half. Looking at my end behavior, as it goes to the left, it goes up. As it goes to the right, it also goes up. I'm going to follow the points, and that gives me my graph.